Hi everyone, this is Mrs. Parr, and on this episode of Math Up to Par, we are going to be talking about equivalent fractions. So when we're talking about equivalent fractions, we're talking about two amounts that are equal to each other. So we're going to show that right now in a few different ways. We're going to start by showing it with fraction bars. So these are fraction bars. And my statement over here says that 1/2 is equal to 3/6, which is also equal to 5/10. So I see right here that I have 1/2, which is equal to 3 of these 6, which is equal to 5 of these tenths. So I'm showing right here what I'm saying over here. So half of this bar, half of this bar, half of this bar. Because 3 is half of 6 and 5 is half of 10, these fractions are equal to 1/2, and I show that right here. Let's show it a different way. Let's show it with area models. So in this picture, I have 2/3, okay? 2 out of 3 are colored in the circle. Over here, I have 6 pieces in my denominator and 4 of them are colored in. So I have 4/6 over here and I have 2/3. You can see that those represent the same amount. So these fractions are equal to one another. These are equivalent fractions. I can also show it on a number line. So I have my number line here, and it starts at 0 and it ends at 1, but both number lines are divided into different size parts. So this number line is divided into 4 parts, so each line represents a fourth. This one is broken into even smaller size parts, so each line in between 0 and 1 represents an eighth. I showed 1/4 being equal to 2/8 because 1/4 lands on the same part of the number line as 2/8. I could also show that 2/4 is equal to 4/8 and 3/4 is equal to 6/8. Let's show it one more way. Let's show it with set models. So a lot of times with fractions we see a set of something. I see right now a fraction, I see 12 total stars, so that's my denominator, and 9 of the 12 are orange. Well, I could show that a different way by kind of looking at them in groups. So I could have a group right here, a group right here, a group right here, and a group right here. So I have 4 groups of 3. So that means my denominator is going to be 4, okay, because there's 4 total pieces now in my circle, and 3 of those pieces have orange stars and 1 of them does not. So therefore, the fraction of groups of stars that are orange out of the total is 3/4. So 9/12 is equal to 3/4. So that's how I can show it and I can prove it. Now, without a model, let's see what we can do to find equivalent fractions. So there's something called the identity property. The identity property is really cool, and it works when you multiply or you divide a fraction or any number by 1. If you multiply something by 1, you get the same number. If you divide something by 1, you get the same number. So because that is true, we can use that to help us find equivalent fractions. So let's say I have 4/5. If I multiply 4/5 by 1, I'm still going to get 4/5. But now I'm going to multiply it, but instead of multiplying it by the number 1, I'm going to represent the number 1 in a different way. I'm going to represent the number 1, so inside my big bubble 1 right here, I'm going to represent the 1 as 2/2, okay? 2/2 is equal to 1, because if I have one circle with 2 pieces and both of them are selected, that's equal to 1 whole. So when I multiply 4/5 times 2/2, I multiply the numerator and the denominator by the same number. And when I do that, 4 times 2 equals 8. And 5 times 2 equals 10, giving me 8/10. That means that 8/10 is equal to 4/5. Let's try it with division. So this time I have 6/9 as a fraction, and I'm going to divide it by 1, and I'm still going to get 6/9. Well, this time I'm going to represent 1 in a different way. I'm going to represent 1 as 3/3, because 3/3 is equal to 1 whole. So now I'm going to say 6/9 divided by 3/3. 6 divided by 3 is 1, and 9 divided by 3 is 3. So to find equivalent fractions, what we have to do is we need to multiply or divide the numerator and the denominator by the same number, okay? And that's because of the identity property. So if we multiply the numerator by 2, we also have to multiply the denominator by 2. If we divide the numerator by 2 or by 3, whatever we do to the numerator, we have to do to the denominator. We have to keep it the same. And that's because that's equal to 1 whole. So let's solve this problem. Which of the following is equivalent to 5/6? So I'm going to write out 5/6 right here, okay? Now, I'm looking at 5 and 6, and I don't see a common factor. And because of that, I can't simplify it. I can't divide the numerator and the denominator by the same number because there's not something that would go in evenly to both. So usually I start by multiplying the numerator and the denominator by 2. When I'm doing that, I'm multiplying it by 2 halves, which is equal to 1 whole. So that's going to give me an equivalent fraction. Remember, whatever I do to the top, I have to do to the bottom. I have to keep it fair. So I multiply straight across. 5 times 2 is equal to 10, and 6 times 2 is equal to 12. That gives me 10/12. I see that over here. So A is my answer. Now, I could also try multiplying 5/6 by something different, and I could get another equivalent fraction. I can multiply the numerator and the denominator by 3. 5 times 3 is 15, and 6 times 3 is 18. So 15/18 is also an equivalent fraction. It's not one of our answer choices on here, but 15/18 is equal to 5/6. So there's always more than one fraction that's equivalent to another fraction. All right, now let's find a fraction that is equivalent to 8/12. So I'm going to take 8/12, okay? And my choices here look like they are smaller. The number in the numerator and the denominator are smaller. Now, that doesn't mean that the fraction's smaller. That just means the size of the pieces are smaller, okay? So I need to find one that's equal to it, but with smaller pieces. So that means I'm going to divide, okay? Well, let me try dividing it by 2. So I get 8 divided by 2, and that equals 4. And 12 divided by 2, that equals 6. Now, 4/6 is an equivalent fraction, but that's not one of my choices here. But I notice that both of these are even numbers. And when that happens and I'm simplifying a fraction, I know that I can go even further. So I can divide it again. When I divide it again, I get 4 divided by 2 is 2, and 6 divided by 2 is 3. And sure enough, 2/3 is a choice. Now, I could have taken a different path to get that answer. I could have said 8/12, and instead of dividing it by 2 and then 2 again, I could have divided it by 4 because 4 is also a factor of 8 and 12. In fact, it is the greatest common factor, which if you understand that can help you with finding equivalent fractions. So when I divide 8 divided by 4, I get 2, and 12 divided by 4, I get 3. Okay, so both times I was able to get the fraction, but I took a different path to get there. Okay, so when you're finding equivalent fractions, sometimes the first thing you try, if you're picking from choices or you're comparing something, you may not find your answer. That doesn't mean it's not right. That just means you might need to try something further or try something different. So now let's look at this step. So we've got a fractional part of this group of triangles that are shaded. So out of the triangles, I see 8 total triangles, and I'm counting 4 of them that are shaded. So that's 4/8. We need to shade the circles below to represent a fraction with the same value. Well, there are 4 total circles down here. I need to create a fraction of these circles that is equal to this fraction up here. So if I'm setting that up, I need to find a numerator. I need to find how many circles I'm going to shade in that's going to be equivalent to this. Well, I look at this and I think, okay, how do I get from 8 to 4? I know that I'm getting smaller, so I'm going to use division. 8 divided by 2 would be equal to 4. And if I do that to the denominator, then I also need to do it to the numerator. If I divide 4 by 2, I see that it equals 2. So that means that I'm going to shade in 2/4 of these circles. Now I have 2/4 shaded. I could also have figured this out by looking at this set of triangles up here and seeing that half of them are shaded in. And if half of this set of triangles is shaded in, because half of 8 is 4, then I could figure out what half of 4 is, and half of 4 is 2, and I could shade it in down here. So there's more than one strategy, more than one way to get your answer. Let's look at the fraction represented in this figure. So the fraction represented in this figure right here is 2/3. Now we need to choose the options right here that show a fraction that's equal to this one above. Well, let's go ahead and name each one of these fractions. So here I see 9 total parts and 6 of them shaded, so I have 6/9. Here I see 8 total parts and 6 of them shaded, so that's 6/8. Here I see 4 total parts with 3 of them shaded, so that's 3/4. Here I have 12 total parts and 8 of them are shaded. And then here I have 6 total parts and 4 of them are shaded. So what I'm going to do is I'm going to take 2/3 and I'm going to multiply it by 1/2, which means I'm going to multiply the numerator and the denominator by 2/2, then again by 3/3, then again by 4/4, and again by 5/5. And I'm going to see what fractions are equal to 2/3. So let's take 2/3 and let's multiply them, starting with 2. So 2 times 2 is 4, and 3 times 2 is 6. So down here, sure enough, I've got 4/6. So now let's try multiplying by a whole, but let's represent that whole in thirds. So I'm going to multiply 2 times 3 and 3 times 3 for 3/3, and I'm going to get 6/9. Sure enough, I have that fraction listed here. Now I'm going to try that again, and I'm going to multiply by 4ths, and I get 8/12. And sure enough, here's that fraction represented right here. Then I'm going to do it one more time and multiply it by 5ths. 2 times 5 is 10, and 3 times 5 is 15. I don't notice any denominators that are larger than 15. So 10/15 is an equivalent fraction, but it's not one of my choices down here. Now, I could keep going on like this forever. I could multiply my numerator and my denominator by the same number for infinity, and I would get equivalent fractions, but those aren't choices down here. So I'm going to go ahead and I'm going to see, okay, I've got 6/8, 3/4. These denominators are smaller than 15, so that means that these ones aren't going to be equal. And I can see that by my visual. There's nothing I can multiply by 2 to get 3. Okay, and here I could multiply 2 times 3 to get 6, but if 6/9 is equivalent to 2/3, then 6/8 can't be equivalent because there's nothing I can multiply by 3 to get to 8. Okay? So I hope that you learned something about finding equivalent fractions. Remember, we use the identity property to multiply and divide fractions by 1/2, okay? And so by doing that, we multiply the numerator and the denominator by the same thing, and we are able to find fractions that have different sized parts and a different number of pieces, but they hold the same value. All right, guys, thanks so much for listening and happy practicing.